Good afternoon. It's really great to be here. Thank you so much for having me. So today we're going to be talking a bit about continuous delivery and how we've managed to start to learn how to apply it at IG Group. My name is David Genn, and I'm the technical lead for our API team at IG. And so today we're going to be talking about why continuous delivery is essential for modern businesses that use software, and some of the particular challenges you have around implementing something like continuous delivery in a regulated financial company like IG, and also some of the lessons from the real-world implementation that we've been doing over the last 3 years. So IG, we're a company you may or may not have heard of. We're based in the UK, and our goal is to provide trading platforms for retail customers. So we provide mobile apps and web apps to allow retail customers like you and I to trade the financial markets. We have about 120,000 active clients around the world, and we process about 4 million trades a month. And over the last 3 years, we've been trying to apply some of the principles from continuous delivery to see how it can speed up the way that we deliver software to our customers. So we're going to start off by talking a bit about what is continuous delivery. We're going to look at some of the particular challenges that a fintech company faces. We're going to look at some of the key principles behind continuous delivery that we try to focus on. We're going to talk a bit about the technical approach that we've taken, and then some of the cultural changes that we've had to make in our software development teams as well. So let's talk about what is continuous delivery. And I'd like to start off by recommending a book to you. This book here, This is Lean. It's an absolutely fantastic book that introduces some of the principles behind Lean, which many people have heard of this principle. It came out of Toyota and is many of the principles behind Lean are the backbone of continuous delivery. And for us to really understand why continuous delivery is a good thing, we really need to understand Lean. And continuous delivery is the idea that we want to be able to push software into production as soon as it's ready. And normally, traditionally, software companies have released their software into production once a quarter, once a month, once every 6 months, whatever frequency works for the company. But in continuous delivery, what we want to do is get that code into production as soon as it's ready so that we can add value to our customers. And Lean is all about that as well. And so in this book, it starts off with an example from the medical profession. And it starts off with a story of a woman who thought she had breast cancer. And so she woke up one morning, and then she decided that because she thought she had breast cancer, she went and booked an appointment with her doctor. So she got an appointment with her doctor later that day, and the doctor said, yeah, I think you've got a lump there that we need to get checked out, so I'm going to refer you to a specialist. And so 2 weeks later, she gets an appointment with a specialist at the hospital. And the specialist goes, yeah, I think I can definitely see something on the scan here. I'm going to need to refer you to have a biopsy taken. So she gets referred to have a biopsy. 3 weeks later, she's able to go and have this biopsy. And she has the biopsy taken, and they send the results off to the lab. And a week later, she's able to go back to the specialist and get the results from those tests to find out if she has cancer or not. And compare that to another woman who woke up and thought she might have breast cancer. And she went to a specialist clinic. And in this clinic, they had everyone on site that was needed to be able to give her a diagnosis. So she turned up at the clinic, and immediately she was able to see a nurse who said, yep, definitely think there's something there we should look at. And she immediately went to see a doctor who did a scan, who said, going to need to take a biopsy of this. And the person to do the biopsy was on site. They could do the biopsy there and then, and the lab was on site as well, which meant that by the end of the day, she could get her diagnosis. And this is the difference between optimizing our organizations to efficiently use our resources or to be optimized for flow. So in the first example, where the woman was sent from doctor to doctor with a big gap in the middle, all the doctors were working really hard. All the nurses were really, really busy. The resources, the doctors, were fully optimized. And this is resource efficiency. But the problem with resource efficiency is that you have these big gaps in the middle. And in the second example, that was called flow efficiency, because it meant that the woman the person who wanted the value got her diagnosis very quickly. Now, it may well have meant that some of those doctors weren't as busy as they could have been. It may well be that no one turned up that day or no one needed a scan. But the woman got her diagnosis incredibly quickly. And this is what continuous delivery is about. It's about, rather than being really efficient with our resources and keeping everyone incredibly busy, it focuses on how quickly can I go from having an idea and getting that idea into production so that my customers are getting value from it. And very often, we work on big batch releases because they're very efficient. We get economies of scale. This is the largest container ship in the world, and it carries, I don't know how many containers, but it's incredibly efficient. And very often, our software processes are like this as well. They're incredibly efficient. We have teams of developers who are kept very busy, and when that development work is complete, we give it to teams of QA, and they're kept very busy as well. And then when we're happy with that, we hand it off to an ops team or a release team, and we have release managers, and they get the code into production very efficiently. But it can take an awfully long time from having the idea to getting the code into production. This is a picture of a smart motorway that we have in the UK, and it adjusts the speed limit on the motorway depending on the volume of traffic. If you have more traffic, you have to slow the speed limit to keep everyone moving, otherwise you get traffic jams. And it's the same in any resource-efficient process. If you've got people coding away as fast as they can, invariably it takes us longer to get that code into production because there's more coordination involved. There's more handoffs between teams. We have things like code freezes to make sure that we can test the software. You need huge amounts of infrastructure to support these really big batch releases. You have to have people like release managers to coordinate everything and delivery managers to make sure everything's included in the release that we need. You have to coordinate promoting loads of code from one environment to the next and then dealing with any of the fallout that comes from that. And of course, we know that in a big batch release, if one thing goes wrong, it can have a cascading effect and impact everything else that's been released as well. So let's compare that to Amazon. Amazon have just started supporting a new product for their Prime customers, where in certain cities around the world, you can get your product delivered to you within an hour. Now, they don't use big container ships or big trucks to deliver something within an hour. They use cycle couriers. There's much less infrastructure needed to get a guy on a bike with a helmet and a bag on his back than to support a huge shipping container. And it allows them to be incredibly flexible and dynamic and react and respond to what the customer needs. And in continuous delivery, this is what we're trying to do. We're trying to move away from having a release process that's like a big container ship with all the infrastructure that goes around it, and trying to be like a cycle courier. You can get that code into production really, really quickly with minimum fuss and coordination. Which just brings us on to the fact that we need to start measuring our effectiveness, not based on how busy we are, not based on how much code we get written, but how quickly can we get that code into production. So traditionally, as agile software teams, we'll measure velocity. That's how much code did you get written within a sprint. Instead, we need to start focusing on, from the time the business had an idea, how many days does it take me to get that code into production? And we need to start measuring that. And so this whole idea, of, well, let's focus on something other than how much code we write, has led to the birth of the continuous delivery movement. And this is a great infographic. We'll share the slides afterwards. That describes all the content that's in a book by Jez Humble and Dave Harley called Continuous Delivery. It's a good book. This is a really great infographic. And this idea about continuous deliveries, it's been around for about 10 years, and these guys from ThoughtWorks have really helped with kind of pioneering it. And the key principle behind it all is this. So we need to encourage greater collaboration between everyone involved in software delivery in order to release valuable software faster and more reliably. And that's the key thing, is how quickly and how reliably can we get code into production. And so at IG, we've been experimenting with this over the last 3 years, and we found that as a financial company, we're pretty heavily regulated. We're delivering regulated products that, depending on the country we operate in, we have a number of different regulators that we need to work with. And this has given us some particular challenges that are not unique to us. Any fintech company will have them as well. So our uptime SLAs, we're dealing with people's money. We can't afford to be down. We have to be up and operating all the time. And so any change to the release process that we bring in has to be absolutely rock solid and stable. We have to comply with various regulation and auditors. They need to be happy with the processes that we're bringing in. So the key thing they're interested in is, how do you know what has changed in your environment? How do you know that what you just changed in your production environment? And in a big batch release, that's much easier to prove to an auditor that you know, because you've got a big list of changes that you're deploying into production. In continuous delivery, if you're allowing teams to release into production anytime they want, then that can appear to a regulator that you may not have as much detail knowledge about what code you're releasing. Actually, the reverse is true. If you're releasing small amounts of change, it's much easier to be specific and to have a paper trail about what you're releasing into prod. Legacy code is also an issue as well. We've offered trading platforms to our customers since the early 2000s, which means we've got a really big IT real estate. And some of those applications are fairly old, and they're not necessarily architected or written in a way that makes continuous delivery easy. And we work on an awful lot of complex cross-team projects as well, which means you have dependencies on changes between those teams. And in a big batch release, it makes it easier to manage those dependencies on the face of it, because you just all release your code at the same time. In continuous delivery, Team A may release their code before Team B. And if Team A is relying on the code that Team B is about to release, it means we need to adopt some new engineering strategies to cope with these dependencies. A lot of the companies that really pioneer continuous delivery, companies like Google and Amazon and Netflix, people like that, they really are able to leverage the power of the cloud and the power of virtualization and container-driven architectures. And being a fintech company, we're less able to leverage some of that stuff at the moment. We have our own data centers, and that's just a reality of working in an audited environment. So it means we've had to adjust the approach we've taken to work on physical service. And the last 2 points are really around attitude. Development teams get very used to, I'm going to write some code, I'm going to put it in test, and then someone's going to test it, and then we'll put it in UAT a few weeks later, and someone will test it again, and then someone eventually will deploy it into production. In continuous delivery, it's the responsibility of the development team to get it into prod as soon as they're confident in the quality, and that requires a real shift in attitude and maturity. And it's the same for testing as well. Very often teams or companies will rely on the idea of a code freeze. You deploy your code into UAT, and then you have days or weeks or however long to test the new version of the software you're about to put live, and nothing changes, which means your QA teams are confident that they're testing what's eventually going to prod. And in continuous delivery, that all changes because all your environments are changing all the time. So there are loads of different companies that have adopted continuous delivery, and it's quite easy sometimes to try and replicate the particular patterns or approaches that they've used. But rather than doing that, what we try to do is really understand the key principles behind continuous delivery. And so we focused on these 4. The first one is that every commit could potentially go to production. Every time you merge to master, you have to assume that that code could go to prod, which means you need to be confident in it. You can't push half-baked changes. The second point is that you need to trust your tests. If we're going to be deploying into code potentially many times a day or many times a week, you can't rely on large manual regression cycles. You need to be in a place where you have enough automated tests that are of high enough quality that if they run green, you're confident with going to production. The third point is you need to automate everything, or automate as much as realistically possible. For the same reason, if you are releasing to code many times a day and you have a manual release process that takes an hour, all your developers will be doing is releasing code. So we need automated processes that make it really easy for our development teams to release code and to release code safely and easily. And the last point, I think, is the most important one, really, which is the idea that you need to separate deployment from release. So there are two risky elements to putting new code into production. The first is putting a new binary into the environment. Is that application going to start up? Is it going to integrate well with the applications around it? Is it going to have a memory leak? And the second thing is releasing new functionality. Is that new functionality going to do what you expect? And so what you want to be able to do is deploy the code into production, make sure it starts up, make sure you're happy with it, make sure that the new functionality is behaving as you would expect in that environment, and then when you're confident, start serving live traffic through it. And then if you discover any issues, you want to be able to easily revert back to the previous version of your software. So I wanted to spend a bit of time going through the technical approach that we've adopted on the API team to help us implement those principles. So the first one is I just want to tell you a bit about our Git branching model. And it's really, really simple. So remember that first principle. Every time you merge to master, it's a release candidate. So every time you merge to master, you're saying, I think this code is ready to go to prod. So this is our master branch. Then imagine we have a new feature we want to work on. We create a feature branch. A whole bunch of developers will collaborate on that and commit to that feature branch. And then when those guys think it's ready, we create a pull request. And once the team's had a chance to review your code and you've made any changes that they've recommended, we then merge that straight back to master. So there's no release branch or dev branch or anything like that. We merge it straight back to master. And at that point, our Bamboo pipeline kicks in. And it creates a new branch that is going to be the release candidate, so release 1.0.0. And it builds that branch, runs tests against it, deploys it into an in-memory environment, and checks it integrates. And then if that passes, we create a tag. And that binary is published up into Nexus. And then once that's done, we push the branch and the tag back to origin. And at that point, we have the tag that can be deployed into our test and UAT and production environments. Now, if we discover an issue in prod, a bug that we need to fix, ideally we'd go through this process again, create a new feature branch and go through all of that. Occasionally that's not possible, so we take a branch off the tag that we've just deployed into prod and rebuild that. The second thing we've done is to go for a blue-green architecture. It's maybe an architecture you're familiar with. It's something that's is reasonably well established now. And the idea here is that we want to be able to deploy a new version of the code into an environment and check we're happy with it before we start serving live traffic. So this is the idea of separating deployment from release. So we're typically working on Tomcat apps. We deploy them into a clustered environment. And in blue-green, you have two copies of the cluster. You have a blue cluster and you have a green cluster. And at any one time, your live traffic is being served to one of those clusters. So in this diagram, the traffic's all going to the blue cluster. And so let's say that we have a new binary that we want to install, a new version of the software. We would deploy it into the green cluster, and no live traffic is being served to it. But at that point, we can test it starts up. We can check we're happy with the logs. We can connect to that environment. We can run our automated tests against that environment, against the green cluster. We can connect to it manually and do any manual testing that we want to do. And then when we're happy, we can just flick a switch in the load balancer and start serving traffic into the green cluster. And we've released the new version of the code. If we discover any problems with that, we can flick the switch in the load balancer again and reroute the traffic back to the old binary that we're confident with. We use Bamboo for our pipelines, and we have a really quite simple continuous delivery pipeline. So as we discussed in the branching model, we merge the code into master, and then Bamboo tags and builds it and runs the automated tests, and it immediately deploys it into the dark environment. So in the previous slide, that was the green cluster. So it just automatically deploys it into that environment with no manual intervention and runs a bunch of automated tests against it. So at that point, you know whether that binary is working or not. And then it's a manual stop. And then it's up to the developers in the team and up to the QA into the team whether they want to release it. And it's just a manual step in the Bamboo plan to release it to the light environment. And then there's another manual stop, and you can choose whether you want to go through the whole process again in our UAT environment and then into our production environments as well. So it's just a copy of that process throughout all of our environments. The other thing we've done is to break up our legacy code into much smaller services. Microservices are definitely a buzzword at the moment, but what we've really found is that taking our large applications and breaking them up into smaller areas means that you have much smaller applications to work on, and it's much easier to make changes to those applications and deploy them independently. And we also use feature flags as well. And these feature flags mean that if we have a dependency on another piece of software that we know isn't going to be in production yet, we can use a feature flag to turn off that piece of functionality. And then when we're confident that dependency is in place, we can just flick a switch and that new functionality is live. And we're using Zookeeper at the moment to do that, and that's working really well for us. So I want to finish off by talking a bit about some of the cultural changes that we've had to make in our teams, which have been as challenging and as rewarding as the technical changes. So Amazon have gone on record talking about their 2 pizza teams. So they say that any software team should be fed by 2 pizzas, which in my case would mean the team was me. But the idea here is that you want the teams to be autonomous. You want the teams to be able to make decisions. You want the teams to own the decisions. And so what we found is that maturity is everything. You need a really mature team. You need a team that is happy to take responsibility for when the code is ready to go to prod. You need a team that's happy understanding what the business need and making sure that gets to prod as quickly as possible based on those priorities. And so what we focused on is self-organization. What we don't want is the team lead having to make all the decisions. I'm now at a point in my team when I don't know when the code goes to production. I find out in the following morning stand-up that an app got deployed to production the following day, which is fantastic. It means that the team themselves are making decisions about when the code is ready to go to prod. We no longer have a distinction as to who deploys the code to prod either, so we have QA on our team deploying code to production on a regular basis, because often they're in the best place to make the decision. They're the ones who are responsible for the quality. They're the ones who are responsible for verifying it. So it makes sense that they're the ones who choose when it goes to production. Which means that we want to move away from this idea that you're a dev, you write code and you deploy it, and you're a QA, your job is to test it. What we really want to do is blur those roles. We want anyone on the team to be able to deploy code into production. And what we want instead is for people to bring a speciality. So you have someone whose speciality is development, but they can get involved in testing. We have someone whose speciality is testing, but they can maybe get involved in writing automated tests. We want to move away from the silos. And we want to embrace bureaucracy as well. We have to audit all the changes that we make into every environment, and actually continuous delivery makes it much easier for us to do that, because we can programmatically determine what code is about to be released into production and audit that automatically without any need for anyone to get involved. And we're not quite in a place where we've automated that whole process yet, but we are able to programmatically determine the code and the changes that we're about to deploy into production. Now, very often we find bureaucracy is just one of those drag things, one of those things that holds us back and we hate doing it and we do the bare minimum. Actually, if we're adopting a continuous delivery mindset, it makes it much easier to do our paperwork even better and to include more detail at a greater level of granularity, which should make our auditors happy. And we need to focus and be clear on the metrics that we're using to determine how successful our teams are. We talked at the start about the benefit of measuring cycle time over velocity. And that's a culture that really needs to be embedded in our teams, which is our teams need to take responsibility for how long it takes us to get code into production, and not just measure velocity and things like that. And this needs to be a discussion within the team, and we need to optimize ourselves around that. If we've decided that the most important thing for us is to get new features into production as quickly as possible, we need to agree as a team the best way that we can measure it. So we're by no means near the end of this journey. Now this is a journey for us. We're partway through it. We're really learning the skills that we need to do continuous delivery well. We're still hitting technical challenges. We're still hitting cultural challenges. But it's really, really exciting to be a part of this journey. And particularly as the company grows, and we've got a lot of developers in London and in Bangalore as well, and we're just opening a new development centre here in Krakow. As the company grows, we need to really spread this culture out with it. So thank you so much for listening. If this is something you'd like to be involved in, please connect with me on Twitter or send me an email. I'd really love to hear your thoughts. But I guess we have time for questions now.
3 minutes, something like this.
Yeah? Yeah. Any questions? Hi, everyone asks that every single time. So the key thing here, which I managed to slip past you or not, is that there's only one database on this diagram. And the database is a big challenge. So there's a couple of things we're doing. One is we're trying to limit the number of applications, our services that connect with the database. So we're trying to move to a much purer service-oriented architecture. So only a few applications are the golden source of truth for the data, and they're the only ones who connect with the database. Secondly, we're trying to make sure that these applications have a dedicated schema, so that if you want to make changes to that schema, it's not going to impact any other schemas around that. And thirdly, we're looking at tools like Flyway and things like that to allow the applications to be responsible for the upgrade of those databases. But it's very difficult to do a database change with zero downtime, and that's one of the things we're really trying to work on at the moment. Yeah, so the question was, do we build every branch that we create? So yes, we do build every branch we create, and but we only save the result of that if the tests pass.
And how do you deal with user sessions, when you switch the cluster from the blue to the green?
So we try and keep our applications as stateless as possible, and we still, so that allows us to not have a dependency on HTTP sessions. One thing we do have to bear in mind, though, is that we still use caching and things like that. So it depends on the application. Sometimes you're willing to take the hit. When you flick over to the new cluster, you accept the fact that those caches have to warm up, and that may be acceptable. We're starting to experiment with ideas around pre-warming the cache in the dark cluster before we flip traffic over. So we're considering that at the moment as to whether that actually helps us or not.
Between the components after the splitting to microservices?
How do you measure the dependency between the components after splitting into microservices? So sometimes there are no dependencies. So what we've had are large monolithic applications, and we've broken those up by functionality, and the idea is that those are totally isolated and segregated. In the cases where we do have dependencies, that's definitely one of the learning experiences we've had, is you've got application A that depends on application B, but you want to get application A out into production, but application B is not ready yet. How do you handle that? So there's a number of things we can do. Sometimes it's just about failing fast. So if a call to that system doesn't work, that's not the end of the world. You log it, but you don't error, and you know the functionality can still continue. The second thing we do, which we're doing more of, is hiding that functionality behind feature flags. So if we know that we're going to be going into an environment and our dependency isn't there, we keep the old flow of code going, and then when we're ready to expose the new flow, we flick on a feature flag. Now what that means is that you end up with a lot of if-else conditions in your code, and we have to be disciplined about going back and tidying those up. And that's still one of the things that we're kind of learning to do, and learning to do that well and efficiently. How do we remove the feature flags from the code? How quickly? It depends on how diligent we're being. Sometimes it's very quickly and you know, a matter of days. Other times it might take us some weeks or months. But it's we're still really trying to work out the patterns of that, because some of those feature flags are binary. It's either on or off. Sometimes it's more of a canary release, like we want to filter a certain percentage of traffic or customers from a certain country. And we might want to keep those feature flags going for longer in case we ever needed to roll back, or you know, we might be rolling that functionality out over a longer period of time.
Your feature branches, how long time do they usually live?
So our sprints are 2 weeks long. So ideally, the longest time a feature branch would ever live would be 2 weeks. But there are scenarios where they live longer. You know, things come up. But 2 weeks should be the longer period of time. It should be less than that normally. How often do we commit bad code into production? Obviously, never is the answer. I mean, it obviously happens. I guess it depends. You know, often if it's a big, more complex project, you know, you might have a higher frequency of that. If you're working on something simpler, it can be fine. But I mean, I guess maybe the question behind the question is, do we actually ever roll back? Do we ever flip back? And yes, the answer is yes. We've definitely done that, and it's been great to be able to get out of Dodge really quickly.
What about rolling back the changes in the database?
Yeah, the old database. Yeah, I mean, doing continuous delivery on the database is, you know, still early days for us. You know, we're still really feeling our way forward. So most of our database changes are done in downtime. So you can roll them back normally then.
So what about the load test? Are you running some load tests?
Yeah, we take, you know, we're a trading company, so performance, latency, throughput is really, really important to us. We run load tests on demand, so we take a call with every new deployment as to whether, you know, to what extent do we need to do load testing on it, and we can run those load tests on demand. So they're pretty much part of the pipeline, but it's kind of a manual addition to it.
Thank you very much for the lecture.
Thank you.